Hello guys, welcome to the lecture series on Sage Math. Today's topic is plotting 2D graphs in Sage Math. So let us start the lecture. Here first topic we are going to discuss is graph of explicit functions. That means writing f of x, writing y in terms of x. Okay, so let us see the first function. F of x I have to define as x into cos of 1 by x. So let us see the simple plot of this. Just select or press shift enter, so it will run. So the graph of x into cos 1 by x can be viewed like this. Now if I want to plot this curve between -1 to 1, so just select f dot plot of -0.1 to 1. Now if you run this, you'll get the curve like this. So you'll get from interval -1 to 1. Now you can do it one more way also, that means plotting of f with an x interval -1 to 1. So even this command also will give the same result. Now I want to write the figure size, okay, so that you can mention the figure size. So here the figure size I have mentioned it as 4. Just run it. So the size of the figure has been reduced, so that you can adjust the figure size as per your wish. Now I want to change the line color as green. So let us see the command. So I have to plot f, interval I have given, figure size 4 I have given, color I am selecting it as green. Even if you want, you can select it as red also. So just run it. We are going to get it as green color. So now I want to add a grid line for this. So you can add the grid line for this. So grid lines is equal to true I have added. So we got the grid lines for this. Now I want to write the title of this graph again. So just one more feature we have to add, that is line style I am going to change. Line style I am going to change it as dotted lines. Dotted lines can be represented as colon, that means in inverted commas colon you have to write line style, and title of the graph you can write it as title is equal to graph of this curve. So just run it. So title of the graph has been set, and line also changed it to dotted lines, and figure size I have given it as 4, and color of the graph I have given it as green. Okay, so in this way we can add features of the graph. Okay, now we are going to discuss about plotting multiple graphs together. So let us plot multiple graphs together. So now I am going to plot these curves. Y is equal to x into cos 1 by x, y equal to x, and y equal to minus x together. So let us see how will you draw this. So here I am going to draw the line. I am going to draw the graph x into cos 1 by x. So just I have run it. Next I am going to draw y equal to x line. Just I have shown the plot. This is y equal to x line. Next I am going to draw y equal to minus x line. So like this in black color. So if you want, you can set it as red or blue something. So here I want to change this black color to red. Red already there, I want to convert it to blue. So just run it again. So your line will come in blue color. So now I want to add all these graphs in a single picture. So I have taken show of P plus P1 plus P2 and the figure size. I have given it as figure size equal to 4. So just run it. This time we got all the three curves in a single line, single picture. Now let us discuss piecewise functions. Piecewise function is nothing but uh, multiple steps. Function having multiple uh, steps. So let us see one kind of piece function. Example 1 I am going to take here. Now I have taken example as x function of x in such a way that in the interval 0 to 1 I should get 1 plus x cube, and minus 1 to 0 I should get 1 plus x. Okay, so just run this. So from the interval 0 to 1 x cube plus 1 you should get, minus 1 to 0 x plus 1 should take. So now I want to plot this. So let us plot this from the interval minus 1 to 1. So if you observe this, just it is going to run now. So now if you observe, from minus 1 to 0 it's a straight line, and 0 to 1 it is a cubic equation. So in this way you can write a piecewise function. Now I am going to give one more example. F1 of x is equal to 1. I have run it. Next, f2 of x I have taken it as 1 minus x square. This is one more function I am defining, and one more function I am going to define it as 2 into x cube minus 3. Just run it. Now piecewise function I am going to define it as minus 1 to 0.5 function 1 should appear, 0.5 to 1.5 function 2 should appear, 1.5 to 2.5 function 3 should appear. So let us see the piecewise function. I am going to run this. F3. So it is defined now. Now I am going to plot f function between the points minus 1 to 1. So if you observe this graph, just it is taking time. Let us see. So if you observe this function, I have mentioned minus 1 to 0.5 function. So that means minus 1 to function 1. Function 1 is minus 1. So y is equal to minus 1 line up to 0.5. Next, from 0.5 to 1.5, it is 1 minus x square, that is a 1 minus x square, it's a parabola. And from 1.5 to 2.5, it is function 3, that is a cubic function. So it is going like this. Okay, now I am going to set this figure size as 5, so it will be looking like this. So here I am going to exclude 0.5 to 1.5, the curve between 0.5 to 1.5. So even you can exclude the curves between the points. So let us observe. So if you observe this curve, I have excluded 0.5 to 1.5. So it will look like this. There is a gap between 0.5 to 1.5. Okay, next let us take an example 2, that is plotting floor function like this. So f1 is nothing but I have taken -1, plot floor of x from -5 to 5. Now here I have to exclude -4 to 5. Just let us see how the graph will be. So -4 to 5 have excluded the graph. So it will look like this. Now let us run this. I am going to insert one graph into another graph. So I have inserted previous graph into this graph. Now let us discuss about implicit functions. So let us see how to draw implicit functions. So here I am going to draw x power n plus y power n is equal to 1. So for that I have defined the variables x and y. N is equal to 101, that means power I am taking 101. F of x is equal to x power n plus y power n minus 1. Implicit plot, implicit underscore plot, f of x range I have given, y range I have given, color I have given it as rosy brown. Just run it. We'll get the plot like this. So now I am going to merge the plots at different stages. So I have taken range of I from 1 to 6. At each stage of n, what is the graph? Let us combine and see. So for that sake I have used the for loop. When I take n is equal to 1, n equal to 2, n equal to 3, what happens? Let us see. So if you observe this, when at different stages of n, you'll get different values of different curves of x. When x equal to 1, x plus y minus 1, it's a straight line. When x is equal to 2, when n is equal to 2, x square plus y square minus 1, that means it's a circle equation. X cube plus y cube minus 1 is equal to, it's a cubic equation. So like that, this is a summation of all the graphs for n is equal to 1 to 6. Now let us see the implicit plots with one more example. So here implicit plots are used where relationships is implicit in an equation rather than explicitly solved. Okay, so that means I have taken one more example. Here I have taken example as the equation e power x is equal to y square, and here for implicit plot I have taken the range as -2 to 2, -3 to 3, line dash line I have put, figure size 4 I have taken, axis true, aspect ratio 1. So let us see if you run this what happens. So this is nothing but one more kind of implicit plot. Now I am going to discuss about parametric plot. So parametric plot in 2D. So here I am going to take the parametric equations as x is equal to t sine 1 minus t square, y is equal to t cos t square between the interval -2 pi to 2 pi. So let us see the parametric plot. So P is equal to parametric plot I have taken. Two equations I have entered here, and interval I have entered it as -2 pi to 2 pi. Color I have taken red. Thickness I have taken 1.2. Text is equal to nice plot. In the plot I will get the text as nice plot. Figure size I have given it as 5. So let us run this. If you run this, parametric plot will be look like this. Okay, along with the text we got nice plot. Okay, now now I am going to express about or explain about polar plot. So let us discuss about the polar plot. So now here I am going to draw the polar plot of r is equal to 1 plus 2 cos s theta, where s is the variable constant, that is n s is equal to 1, 1.01, 1.02 like that. So I am going to range the theta as 0 to 200 pi. So let us see with an example. So here I have taken the plot 1 plus 2 cos s theta, theta ranging from 0 to 2 pi, points 5000 points I have taken, with the thickness 0.5 and figure size as 4. So let us see. If you run this, you will get the plot, polar plot like this. Now I am going to draw two polar plots in one picture, that is this is one more polar plot. I have given the fill shade also for this. So in plot 1 I have taken 0.5 into cos 4t plus 2.5. This is one graph I have taken between 0 to 2 pi, and the color red I have taken, and one more curve I have taken it as 4 cos 4t plus 1.5, having the interval 0 to 2 pi. Filling is 0.5 into, that means I have to fill this curve with shade as gray. So I am going to club these two. So we'll get the polar plot as like this. Now region plot I am going to draw. So let us see the region plot. So I am going to draw the region plot of this curve. -1 by 2 less than or equal to xy less than or equal to 1 by 2. Here region plot I have taken it as x into y less than or equal to 1 by 2, x into y greater than or equal to -1 by 2, and limits I have taken, or x range and y range I have taken it as -2 to 2, and in color light green I have taken, out color light blue I have taken, border color I have taken as black, figure size I have taken select it as 4. Now let us see. So green color, in color represents this one, out color represents blue here, and xy plot, as you know, y is equal to 1 by x plot. This, since I have taken from -2 to 2, the graph will look like this. Now I am going to draw one more example. Region plot of x into x minus 1 into x plus 1 minus y square. So just see the region plot of this equation. This is one more example of region plot. Next I am going to discuss about polygon plotting. So let us see the polygon plotting. Now just run with an example 1. Example 1 I have taken as a set of points with orange and black. I have filled, thickness I have given it as 3, sum of a plus b, show of a plus b. So if you take the 4 points, so inside of the graph I have taken it as orange, and outside of the graph outline I have taken it as orange, black line. Okay, so that with the thickness of line as 3. So you can draw a nice plot like this. Let us see then one more example. Now let us see. I have taken one more set of points as -1 to 0, 0 to -1, 1 comma 0, 0 comma 1. Color I have taken it as golden rod, and edge color I have taken it as black. Now let us see. So this is the plot I got for those 4 points. Now let us discuss about creating a graphing array. So let us start it. So example 1 I am going to take. Here I am going to define 4 functions total. One is f of x is equal to sin x, g of x is equal to 2x, sin 2x, h of x is equal to 4x. Plot 1 I am taking from f from -2 pi to 2 pi, having coloring it as red. Next, plot 2 I am taking it as g, -2 pi to 2 pi. I am going to set it as green. Plot 3 I am going to write it as parametric plot, having first and second, that is gf and g. Next, one more parametric plot I am going to draw, that is f and h. So I am going to combine all these 4 graphs. So let us run it and check. So you are going to get the parametric curves and normal curves in a single picture as like this.